Japan's Hakudo R lander makes a crater on the moon again. Stoke and Firefly show off engine testing for their new upcoming rockets. Falcon 9 celebrates its 15th anniversary, and we've got a ton more space drama on social media. All that and more coming up this week in Spaceflight. For the past 6 months, we've been following the second Hakudo R mission from Japanese company Ispace on its journey to the moon. And while we finally saw the culmination of that story this week, it unfortunately did not end the way that we hoped. At this point, it seems very likely that the lander added another crater to the moon's surface. So what happened? Well, let's start from the beginning. The Hakudo R lander was launched towards the moon on January 15th, together with Firefly's Blue Ghost lander. Blue Ghost touched down on the lunar surface in early March, but Hakudo R went the long way round on a much longer but more fuel-efficient route, trading propellant for time. Now, this wasn't Ispace's first attempt at landing on the moon. The first Hakudo R mission crashed into the lunar surface in April of 2023. It was later revealed that the lander's computer misinterpreted its sensor data, and it tried to touch down 5 kilometers above the lunar surface. It hovered until it ran out of propellant and then plummeted to its demise. With this second mission, Ispace hoped to correct the mistakes and even named the new lander Resilience. Unfortunately, it just wasn't meant to be. After a successful launch and journey towards the moon, Resilience prepared to touch down in Mare Frigoris on June 5th, and initially all seemed to go well, but just 90 seconds before expected touchdown, telemetry was lost. Now, based on what we saw in the seconds before, it appeared to be descending much faster than it should have been, and the faces of the people in mission control gave away more than any piece of telemetry ever could. For everyone at Ispace, we feel you. Landing on the moon is no easy feat, but Resilience still managed to tick off 8 out of its 10 milestones, which is great. Hopefully the next attempt will touch down a bit softer. Ispace later confirmed in a press briefing that Resilience did not successfully touch down on the lunar surface, at least not softly, and that the lander sent its last bit of telemetry at 192 meters above the surface. The company is now investigating the root cause, but they believe it's a different issue than what caused the failure of the first mission. They found that the altitude measurements from the laser rangefinder were delayed, and that the lander did not decelerate enough as a result. The company wants to incorporate learnings from this mission into their next vehicles. That next landing attempt is currently scheduled for 2027, when Ispace's division in the United States will land the Apex 1.0 lander. Ispace is working on that lander for NASA's Commercial Lunar Payload Services as part of Team Draper. But it's not just NASA that wants Ispace to land on the moon. Ispace's European division in Luxembourg developed a small rover called Tenacious, which actually flew on board Resilience during the second Hakudo R mission. The European Space Agency happens to want a rover of its own, so this week Ispace announced that its European division signed a contract with ESA to build one for its mission for advanced geophysics and polar ice exploration, or McPike for short. The project started late last year, but ESA has awarded a contract extension for the implementation phase. And if all goes well, this will be the first ESA-led mission to explore the lunar surface. So best of luck to Ispace for next time. We all hope that your next rover gets to do what Tenacious was supposed to do and drive towards the lunar sunset. Okay, time to talk politics, but let's start at the top with the full presidential budget proposal for NASA for fiscal year 2026 that was released at the end of last week. You might remember we already talked about some of the proposed cuts to NASA about a month ago when the White House released what's often called the skinny budget, which is essentially a really short version of the presidential budget proposal. With the full proposed budget now released, there's a lot more details about exactly what sorts of things are proposed to be cut and what other things are getting funded. Overall, the budget proposes to cut NASA's budget by about a quarter, going from about $24.9 billion in the current fiscal year down to $18.8 billion for the next one. As already outlined in the skinny budget, the budget proposal would end NASA's SLS rocket and Orion spacecraft after the Artemis 3 mission. The proposal would also cancel the Gateway lunar station as well. But there are also some additions to the budget regarding human spaceflight, as it proposes a commercial Moon to Mars infrastructure and transportation program. This program would include the development of commercial means to send astronauts to the moon, therefore replacing SLS and Orion, as well as developing critical infrastructure for Mars crewed missions, such as spacesuits and a communications network. The budget proposal also includes a Martian version of NASA's commercial lunar payload services and funding to carry out a demonstration mission of entry, descent, and landing of what it calls a human-class Mars lander. Now, generally speaking, most of these proposals may resonate with a lot of space fans out there, but what have definitely not gathered a bunch of support are the proposed cuts to NASA's science programs. The budget proposal would see NASA's science budget pretty much cut in half, mostly due to the cancellation of dozens of science missions that are either in development or are already in space but have been operating for a long time. The latter is the case for the Chandra X-ray Observatory, for example, which, despite still working and gathering science, would be turned off to save money on its operations. In that bucket, we can also add missions like New Horizons, Juno, Maven, Mars Odyssey, OSIRIS-REx, the Fermi Gamma Ray Telescope, and many others. Some ongoing missions, such as the Hubble Space Telescope or the James Webb Space Telescope, would remain funded, but at lower levels. The agency would also continue to develop and eventually launch the Nancy Grace Roman Space Telescope, but also at lower funding levels than originally planned. But others that were in development, such as the Da Vinci and Veritas missions to explore Venus, are being proposed for cancellation, as well as the Mars Sample Return mission. NASA would also end some of its international science collaborations, which includes, once again, NASA pulling out from the European Space Agency's ExoMars mission and its Rosalind Franklin Mars rover. Along with those missions, the Earth science budget would also be cut by more than half, again by cutting certain missions in development and phasing out those that are later in their missions. In the space technology side of things, the budget proposes to end work on the Draco project to develop a nuclear-powered rocket engine that was slated to be launched later this decade. While there exists some debate in the community as to whether this type of propulsion would really be useful or not, the budget still cancels other sorts of nuclear-related items, such as the production of plutonium-238 that's used on radioisotope thermoelectric generators. Now, these are key to power science probes in deep space, and are also critical for science missions such as the Curiosity and Perseverance rovers. A cancellation of this technology would also mean there'd be no way to use nuclear power for potential future missions to the Martian surface without using large solar panels. Needless to say, many of these cuts are not popular at all, and it would have been interesting to see the current administration try to defend their proposals to Congress, who certainly has different opinions. For example, just this week, Ted Cruz, senator for Texas and chairman of the Senate Committee on Commerce, Science, and Transportation, released a budget reconciliation bill. The bill proposes keeping the funding for SLS and Orion through Artemis 4 and 5, funding Gateway, and funding a Mars telecommunications orbiter to support missions such as sample return, future human missions, and more. Now, of course, when it comes to defending the president's goals for NASA to Congress, that work falls to the NASA administrator. And while when the budget proposal was released, the nominee for NASA administrator was Jared Isaacman, that is no longer the case. Over the weekend, news broke that President Trump had rescinded Isaacman's nomination for NASA administrator. Trump later confirmed these reports on social media, citing prior associations, aka Democratic donations, as the reason for the withdrawal. Isaacman also went to social media with his own statement, noting bipartisan support for space and thanking the US president for the opportunity. That, however, didn't stop rumors from swirling and seeming to point to the eroding relationship between Trump and Elon Musk as the reason for the president to pull Jared's nomination. It was clear that Musk had been supportive of the nomination and may have even contributed to it, so the rumors actually sounded reasonable. And just when you thought that was the bulk of the space drama for the week, buckle on up. In recent days, Elon has become more and more critical of a few of the Trump administration's decisions, not just Jared's nomination being pulled, but also regarding many other non-space matters like the government spending. The criticism then developed into a back and forth on social media on Thursday that eventually crossed into space territory, which is why we're covering it here in case you were wondering. It specifically crossed into space territory when Trump suggested that a way for the government to save money would be to cancel contracts with Elon's companies, which obviously includes SpaceX. Elon then retaliated by stating that in response, quote, SpaceX would begin decommissioning its Dragon spacecraft immediately. This threat, so to speak, was pulled back, though maybe sarcastically, when another user on X advised Elon to cool off and step back. But with these guys, you never know what might happen next. It's well known that the government has a lot riding on SpaceX when it comes to space. On the civil side, NASA has billions in contracts with SpaceX to launch astronauts and cargo to the International Space Station. SpaceX's Falcon 9 and Falcon Heavy rockets regularly launch NASA's science missions, and the agency also has a multi-billion-dollar contract with SpaceX for the company to deliver astronauts to the lunar surface on Starship. On the military side, the Pentagon also now has many of its space missions flying on Falcon 9 and Falcon Heavy rockets. They make use of SpaceX's Starlink satellite constellation in the field, and they're even launching their own satellite mega constellations, yes, that's plural, on Falcon 9 rockets. The Air Force is also interested in SpaceX's Starship for point-to-point cargo delivery and has a contract with the company to demonstrate that capability in the near future. So pulling out of many, if not all of these contracts with SpaceX could leave quite a hole in US capabilities in space. Not to mention, we go back to paying Russia for seats to the ISS? And how does it safely get decommissioned without a deorbit vehicle? For SpaceX, it probably wouldn't be that big of a deal, as now the majority of its revenue comes from Starlink. However, that too could be affected if the administration decided to use the Federal Communications Commission to threaten Starlink. And there's already precedent for similar actions. So as for what might happen in the future, who knows? Maybe this all turns into nothing and we're all back to square one in a few days, but maybe it doesn't. And if not, we're gonna see some major changes in the US spaceflight landscape. Whatever happens, it's surely gonna give us a lot to talk about. And if you want to stay up to date with all of the chaos going on in Washington, be sure to subscribe to our channel and get notifications for whenever we go live or drop a new video. And while you're at it, why not toss us a like too? While NASA's budget, especially its science budget, is in turmoil, its existing astrophysics programs are still delivering results. The agency continues to work on its upcoming missions, and a pair of new observatories have passed key milestones on their way to space. One of them is IMAP. No, not the email protocol, but rather NASA's Interstellar Mapping and Acceleration Probe. The IMAP spacecraft was trucked into Kennedy Space Center from the Marshall Space Flight Center on May 10th, and it's now out of its shipping container and being processed in the Astrotech Space Operations Facility before its launch this coming September on a Falcon 9 from historic Pad 39A. IMAP's mission is to better understand the boundary between interstellar space and the sun's heliosphere, which is the part of space influenced by solar wind. After launch, IMAP will make its way 1.5 million kilometers away from Earth to the L1 Lagrange point, where it'll make observations about solar winds, particle acceleration, and magnetic fields using 10 different scientific instruments. While the IMAP telescope is now at KSC and being prepared for launch, the long-awaited Nancy Grace Roman Space Telescope also successfully passed a key milestone on its own way to the launch pad. The Roman telescope's inner core portion was recently shaken to 125% of the stresses expected during its launch aboard a Falcon Heavy. This core consists of the telescope itself, the spacecraft, the instrument carrier, and its two main instruments. It passed the test at the Goddard Space Flight Center in Maryland and will now be inspected to make sure that everything is still aligned correctly. Roman is still on track to finish assembly later this year for a launch no later than May 2027. And yes, that's no later than, because NASA is actually on schedule for this one. We also just got some new science results in from the Hubble Space Telescope, which teamed up with ESA's recently retired Gaia spacecraft. For a long time, astronomers have believed that the Milky Way, our home galaxy, is on a nearly certain collision course with the Andromeda Galaxy, also known as Messier 31. However, using information from Hubble and Gaia, scientists have found that this collision is actually looking less likely, with only a 50-50 chance of happening now. Astronomers ran simulations using data collected by Hubble and Gaia and found that the path the galaxies take through space is affected by smaller satellite galaxies. The Large Magellanic Cloud, a satellite galaxy of the Milky Way, alters the path of our own galaxy, while Andromeda's satellite galaxy, Messier 33, does the same with Andromeda. Combined, these can change the paths of the galaxies so much that they might not even collide at all. So while astronomers were pretty convinced that the galaxies would collide in about 4.5 billion years, they now believe there's only a 50-50 chance that this might happen in the next 10 billion years. But either way, that's still far enough in the future that we won't really have anything to worry about. And speaking of galaxies billions of years in large space telescopes, the James Webb Space Telescope just found the oldest galaxy ever seen. Astronomers spotted the galaxy in images taken by Webb for the Mirage or Miracle survey. The galaxy has a redshift of 14, which is pretty significant. Now, redshift is a measure of how much the light from a galaxy has changed as a result of the universe's expansion. Before groundbreaking technology like Webb, astronomers found detecting galaxies with a redshift higher than 10 pretty challenging, though Hubble had found one with a redshift of 11. This newly discovered galaxy existed only 280 million years after the Big Bang, which is insane, just 280 million years after the universe itself was created by the Big Bang, about 13.8 billion years ago. And Webb might even find older galaxies soon. It recently used, essentially, a gravitational lens to image some other very distant galaxies. This lens occurred as a result of a cluster of galaxies 4.5 billion light-years away, which effectively acts to bend the light of the galaxies behind it. Thus, these background galaxies now show up as magnified, distorted shapes. Among these distorted background galaxies may be galaxies that existed even earlier, as little as 200 million years after the Big Bang. The image even shows hints of the very earliest stars. When Webb was launched on Christmas Day in 2021, it was expected to excel at just this very kind of research, and wow, it has certainly delivered. Now we'll take a look at some other stories across space, starting with Gilmour Space, which has completed its investigation into the premature fairing deployment that caused them to stand down from the maiden launch of their Eris rocket last month. The rocket was poised to become the first orbital launch from Australian soil in over 50 years, and the very first orbital launch by a homegrown vehicle. Despite lighthearted posts on social media featuring an unexpected guest, it turns out that the fairings weren't triggered by a visiting cockatoo. The company instead found that an unexpected power surge had caused the Eris vehicle to shut down and, in the process, caused the deployment of the fairings. The issue is traced to an electrical backfeed from other devices further downstream during vehicle checks the night before launch, so Gilmour Space is now installing additional safeguards to protect against this in the future. The team will then perform a system test to verify these changes ahead of the next launch attempt from the Bowen Orbital Spaceport. We don't yet have a new date for the maiden launch of Eris, but we're looking forward to seeing the company have more than just the fairings take off on its next attempt. Firefly Aerospace has completed another full power test of its Miranda engine. 7 of these tap-off cycle engines will ultimately power the first stage of the forthcoming Eclipse rocket. The test lasted for the full 206 seconds of engine burn that'll propel Eclipse from the launch pad into orbit when it takes its maiden launch next year. The vehicle is targeting a gap on the medium-lift launch market and, like the Falcon 9, has been designed for reusability. The company plans to propulsively land the first stage back at the launch site on later missions, once performance and reliability have been proven in earlier flights. Eclipse builds on decades of flight heritage from both Firefly's Alpha and its partner on the project, Northrop Grumman. It takes flight-proven avionics from the Antares program and adds to it Firefly's advancements in propulsion and carbon composite structures. Additionally, the first stage of Eclipse will be used on the Antares 330, which will also make its debut next year, as it's scheduled to carry the NG-24 cargo mission to the International Space Station on that first mission. Both rockets will launch from the Mid-Atlantic Regional Spaceport, or MARS, on Wallops Island in Virginia. But Firefly wasn't the only company to test engines for a reusable medium-lift rocket this week. Stoke Space also shared a video of a full-duration test firing of its methane-fueled Zenith engine. Zenith will power the first stage of Stoke's upcoming Nova rocket, a fully reusable rocket made out of stainless steel. And yes, it's going to be fully reusable, including its upper stage. Nova's first stage features 7 of these Zenith engines, which run on the full-flow staged combustion engine cycle. It's notoriously challenging and has so far only been flown on SpaceX's Raptor engine. Despite the complex engine cycle and ambitious rocket design, Stoke has still been moving at impressive speed. This week, they fired Zenith for the full 200 seconds that it's expected to run on a mission. During this test, Stoke put the engine through its paces by testing the full range of power levels and propellant mixture ratios, and it seems that Zenith held up really well during the tests. We're excited to see what's next on the path towards Nova's first flight. And believe it or not, there was even more engine testing this week, as India also was testing engine parts. The Indian Space Research Organization is working on a new core stage for its LVM-3 rocket. The current core stage is powered by hypergolic propellants, which have the disadvantage of being extremely toxic. The new core stage, called the semi-cryogenic propulsion stage, will be powered by kerosene and liquid oxygen, which not only have the benefit of being safer to handle, but also add some additional performance. This year, ISRO has been testing the engines for the stage, or rather the engine's power head. The main focus of these tests is to fine-tune the engine's startup sequence. Last week, the test article fired up for the third time and operated at up to 60% of its design power level. The test was short, it only lasted 3 seconds, but that was enough to demonstrate, quote, stable and controlled performance. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. Kicking off the week, we had the 32nd launch of Blue Origin's New Shepard rocket, and this one, just like the previous, had 6 passengers on board. Liftoff took place on May 31st at 13:39 UTC from Launch Site 1 at Blue's own spaceport in West Texas. On board were Paul Jarris, Jesse Williams, Amy Medina Jorge, Dr. Gretchen Green, Jaime Aleman, and Mark Rocket. And yes, his last name is actually Rocket, that's not a joke. For this flight, Blue was flying the older New Shepard capsule, RSS First Step, which made its 13th flight. The New Shepard booster was Tail 4, which flew its 14th flight. And both capsule and booster made it back safely to Earth. From Texas, we now go to California, where a Falcon 9 took off on May 31st at 2010 UTC, carrying a batch of Starlink V2 mini satellites into orbit. The first stage for this mission was B-1071, flying for the 25th time, becoming the 3rd booster to fly that many times. It successfully returned to Earth, landing on SpaceX's drone ship Of Course I Still Love You. And that was the 28th and last orbital launch of the month of May. As usual, SpaceX continues to be the most active launch provider, putting the United States at the top of the list of most launches worldwide. The company launched 16 Falcon 9 missions in May, matching the record for the most Falcon 9 launches in a calendar month, and that's on top of the Starship launch that took place in May as well. And starting off the month of June, we had the launch of Rocket Lab's Electron rocket from New Zealand, carrying out the full Stream Ahead mission. The mission started on June 2nd at 23:57 UTC and carried the second Black Sky 3rd generation satellite into low Earth orbit. These satellites are commercial Earth observation satellites built by Black Sky. The 3rd generation of satellites have a higher resolution imaging capability and are able to image in greater wavelengths than the previous generation. Not long after Electron, we had another Starlink launch, but this time from Florida. That launch took place on June 3rd at 4:43 UTC, carrying a mixed batch of Starlink V2 Mini and Starlink direct-to-cell satellites into orbit. The first stage for this mission was a veteran one, flying for its 21st time, and it successfully landed on SpaceX's drone ship Just Read the Instructions. And in another quick turnaround of assets at Vandenberg, SpaceX launched another Falcon 9 rocket, carrying another batch of Starlink V2 Mini satellites. Liftoff took place on June 4th at 23:40 UTC, and in case you forgot, June 4th was Falcon 9's birthday. It was on June 4th, 2010 that Falcon 9 first took off to the skies, and here we are still going strong 15 years later. Now, depending on how you count launches, either this Starlink launch from Vandenberg or the previous one from Florida also represented the 500th launch of the Falcon family of rockets, including Falcon 1, Falcon 9, and Falcon Heavy. The discrepancy is in Falcon 9's one suborbital launch, the Crew Dragon in-flight abort test back in 2020. So if you're only counting orbital launches, then the Vandenberg Starlink was the 500th launch, but if you count the suborbital one, then it was the previous one. Everyone loves numbers, am I right? Of those 500 launches, 484 were Falcon 9 launches, so in a few weeks, we will likely have the 500th launch of Falcon 9, which is also really impressive to think about. And if you like even more stats, the booster flown on this Starlink mission was B-1063, and it flew for its 26th time, making it only the second booster to reach that milestone. It also made it back to the deck of Course I Still Love You, and we may see it fly again really soon. Wait, what? You want even more numbers? Alright, well, with the Starlink launches of this week, SpaceX has now launched a total of 8,851 Starlink satellites since the first Starlink launch, of which 1,158 have now re-entered, and 6,715 have moved into their operational orbit. And to wrap up the week, we had the launch of a Changzheng 6A from China on June 5th at 20:45 UTC. The rocket was carrying a batch of Guowang internet satellites into low Earth orbit. These satellites are part of China's own Starlink-like satellite internet constellation created and developed by CASIC, the China Aerospace Science and Industry Corporation. This is now the 4th operational launch for the constellation and brings the total number of these satellites launched to over 30. Going into next week, we'll see a lot more action in space with a number of Falcon 9 launches scheduled. Some of them will be Starlink launches, but 2 of them will be carrying customer payloads. One is planned to launch the SXM-10 satellite into geosynchronous transfer orbit for SiriusXM, while the other is slated to launch Axiom's 4th human spaceflight to the International Space Station. That launch, currently planned for June 10th at 12:22 UTC, will feature the 5th and final Crew Dragon capsule to be manufactured by SpaceX. From now on, if they still launch Dragon after all the drama on social media, SpaceX will just be reusing the already existing capsules until the spacecraft is retired. Next week, Rocket Lab is also planning another Electron launch, and China may pop into the schedule as well. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.